Recrystallization is a purification technique taught in both general and organic chemistry. In this experiment, we'll purify an impure sample of benzoic acid. For both general and organic chemistry students, we'll learn the skill of recrystallization and characterizing the pure sample by finding its melting point. For organic chemistry students, we'll add the skill of using vacuum filtration and a Buchner funnel, as well as using infrared spectroscopy to analyze the pure sample. For our recrystallization, there are three main factors to the technique: the solvent, heat, and time. Let's discuss. First, choosing a solvent is important because we can separate insoluble impurities from soluble components. Soluble means dissolve in solution, and insoluble means does not dissolve in solution. For example, in this lab, we'll use boiling water to dissolve an impure sample of benzoic acid. We'll take advantage of benzoic acid's high solubility in boiling water, or water at 100 degrees Celsius. Benzoic acid will dissolve, and the impurities will not. It is also important to choose a solvent that does not react with any of the substances in solution. Any insoluble impurities can easily be filtered out in what we call a hot filtration, using a vacuum and a Buchner funnel. This is because we want to keep the solution hot, so benzoic acid doesn't freeze out and is filtered out. We want the benzoic acid to remain in solution. The next factor is patience and time. By allowing the solution to cool very slowly, the benzoic acid molecules are allowed to find each other via intermolecular interactions. Time allows the molecules to form a pure solid crystal. This means that the benzoic acid molecules can form the points of the pure crystal lattice. The crystal lattice is the desired geometric shape of a pure crystal, if allowed to form slowly and naturally. By doing so, any soluble impurities will have been pushed out during the crystal lattice formation and remain in solution. A second, cold filtration, filters out the solid benzoic acid crystals. Thus, the impurities remaining in solution are separated. In both general and organic chemistry, the pure crystals can be characterized for their purity by finding a melting point. Pure benzoic acid melts near 121 through 123 degrees Celsius. If our sample melts at this temperature, then we can safely assume it's a pure sample. If impurities remain in the solid crystal lattice, then the melting point is lower and broadened due to weakened intermolecular forces due to the presence of impurities. For organic chemistry students, a sample can be characterized by obtaining an infrared or IR spectrum. We can check for expected peaks of benzoic acid in the functional group region. Any unexpected peaks signals the presence of impurities. Let's look at the experiment. But first, here's what our data section will look like. You'll notice we'll measure the initial mass of the impure sample. Then, toward the end of the experiment, we'll measure the mass of a weighing boat and 2 filter papers. This is because the final step is to filter the benzoic acid crystals, then reweigh the weighing boat and 2 filter papers with the crystals. By subtracting the mass of the weighing boat and the filter papers, we can obtain the mass of the pure benzoic acid crystals. Then we'll calculate the percent recovery with this equation. The percent recovery tells us the amount of benzoic acid in the impure sample. This may be useful to know for some chemists in certain situations. Finally, we'll get the melting point and IR spectrum. Now let's look at the lab, and I'll add commentary when appropriate. The idea here is to heat the Buchner funnel in preparation for the hot filtration. After setting up the vacuum filtration, use the hot hands to place the Buchner funnel on the vacuum flask. Then, run some hot water through the Buchner funnel to wet the filter papers. Remember, you want to keep the funnel as hot as possible. Otherwise, the benzoic acid will freeze and clog the funnel. You can see here that even with the hot filter paper, some benzoic acid crystals formed on the filter paper. I'll run some hot water through the funnel and you'll see that the crystals redissolve. You can see the benzoic acid frozen in the filter flask. This is not what we want. We want the benzoic acid to recrystallize slowly. So we'll place the flask back on the hot plate after adding some boiling stones. We'll boil until the final volume is about 50 milliliters or less. I'll run some ice-cold DI water through the Buchner funnel. It's likely you'll have some crystals stuck on the walls of the flask. Use some DI water to wash more crystals out of the flask. Let the crystals sit in the funnel for a few minutes. This will dry the crystals. Use the metal spatula to move the crystals around. If the crystals stick to the spatula, then the crystals are still wet. Dry crystals will not stick to the spatula. We can see the broad OH peak of the carboxylic acid OH group between about 2300 wave numbers and 3300 wave numbers. We also see the strong carbonyl peak near 1725 wave numbers. And finally, we see the medium carbon-carbon peaks of the aromatic ring between 1500 wave numbers and 1600 wave numbers.